Saxon Advanced Mathematics, Lesson 92. We have a two-topicer today. This is pretty relaxed content today, so kick back, put your feet up. I hope it's the end of your week. And wrap your mind around some interesting scenarios that aren't all that difficult. The first topic is called the probability of either. That's really weird, and it always looks like probability of ether to me, like if you drop the I out. Ether is what was used when I was a really little kid. That's what they used to put you under for surgeries. Is that true, or was it before my time? I don't know. I didn't have surgery when I was little, but when we've talked about probabilities up until now, we have talked about mutually exclusive events, which makes no sense. I'll explain what I mean. All right, the typical thing that we've talked about is like marbles in an urn, right? And we'll say, oh, there are 3 red, and there are 4 black, and there are 6 white. And then we might say, what's the probability of getting a red or a black? And we would say, oh, okay, well, red or black are those two. That's a total of 7. And then you add the 6 whites because there's 13 in all. Simple, right? Very straightforward. Another way that we can write this is the probability of red union B. Okay, that's a fancy way of saying it, but that just stands for union, or as we say it in a sentence, the word or, right? We wrote red or blue, so red union blue. That means it's the combination of both of those things. So they can be either red or blue. So this is a new way of saying what we have said all along. In this case, we can also say something different. The probability of getting red intersected with black is 0. Because what this is saying, we use the word intersection, which means essentially both. Is there any way that red marbles are also blue marbles, that they're both red and, oh, I'm sorry, not blue, black. Are they both red and black? That's impossible, right? With marbles, you're one color or the other. You're mutually exclusive. You can't be both. So this language makes no sense in the kinds of problems that we've dealt with so far. This would have the same answer. Doesn't look like it, right? So the probability of getting a red or a black is 7 out of 13, just as we calculated it in the past. The probability of getting a marble that is both red and black, it's impossible. Marbles don't work that way. Now you know that we're going to talk about what we call non-mutually exclusive events. And this is where it gets a little weird. Let's take, for our example, a group of boys. A group of kids in a room, boys and girls, all right? Here are the boys. There are 1, 2, 3, 4, 5, 6, 7 boys. This group is not the girls because we don't have girl boys. I mean, gender identities have come a long way. This is a problem that might be reworded differently, but what we're looking at here in this circle are not the girls, but the redheads in this group of children. And there are a total of 4. Now we have to sprinkle in a few more dots because these are the girls, all right? So here's our situation. We've got a group of what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 kids. 1, 2, these are all the boys. So it looks like what? 7. 1, 2, 3, 4, 5, 6, 7. There's 7 boys. There's 4 redheads, but being a boy and a redhead are not mutually exclusive. So we have some redheaded boys. My grandfather was redheaded, so I'm thinking of him. My grandfather and my mother were super redheaded.